Today we will look into multi-step equations with variables on both sides. Our steps to follow are: first, distribute and simplify each side. Simplifying will involve combining like terms. 2. Isolate the variable using inverse operations. We are going to gather all the variables on one side and the numbers on the other side of the equation. Number 3. We are going to use check steps to check our answers by substituting the result into the original equation, and it should give us a true result. We're going to go through 3 different types of solutions. We may have one real solution, we may have no solution, and we may have infinite number of solutions for the given equation. Here's our first example. On this example, we have like terms on one side and like terms on the other side. I will only combine the like terms on the same side of the equal sign with each other. So on the left side, I only have numbers to combine. On the right side, I am going to combine the x's with each other. If we do the combination here, 33 and 2 is going to be 35. X plus 35 is on the left side. And on the right side, positive 2x, negative 6x will make negative 4x, and minus 5. Now we are going to gather the variables on one side of the equal sign. Let's get rid of the x's on the right side so we can only have x's on the left side. In order to get rid of a negative 4x, I will add positive 4x on both sides of the equal sign. And when I do that, I will be able to add these two, which will add up to 0, and they will be eliminated. And we will only have negative 5 left on the right side. And on the left side, x plus 4x is going to be 5x, and we still have 35. We will then subtract 35 from each side to eliminate the variable, to isolate the variable. We will leave the variable alone. To do that, we subtract 35 from each side. Next, we have 5x is equal to negative 40. If I divide each side by 5 as my last step, we will have x is equal to negative 8 as our final answer. We can also do a check step. Here's my check step. I will write my original equation, 33 plus x plus 2 is equal to negative 5 plus 2x minus 6x. I want to check to see if x is equal to negative 8 was correct, so I want to substitute that x into the original equation, and it should give me a true result as far as one side being equal to another. But let's plug it in. 33 plus negative 8 plus 2, is it equal to, that's what we are checking, negative 5 plus 2 times negative 8 minus 6 times negative 8. Let's evaluate each side separately with order of operations. 33 and negative 8 would be positive 25 plus 2. Is it equal to negative 5 plus negative 16 minus negative 48? We will continue our operations. 27, is it equal to this? These two would be negative 21. Subtracting a negative is positive, plus 48, and 27 is, yes, equal to positive 27. Because this answer is true, that means our answer, x is equal to negative 8, was correct. That's how we can check our work. That's how we can check our work to make sure that we got the correct answer. Now here is your U-try. Please try this on your own. 11w minus 9 minus 7w is equal to 15. Combine like terms on each side. Try to isolate your variable, and you can check your work to confirm your answer. Here's your second U-try. 23 is equal to negative 4m plus 2 plus m. Isolate the variable, then substitute your result into the original equation to do a check step. This is 2 plus m. Let's go to a second example where we have to do a distribution. Before I combine like terms, I have to do distribution. So here's my distribution step. We will have 5h plus 2 times 11 is 22. 2 times negative h is negative 2h is equal to negative 5. I will then combine like terms on each side separately. We will have 3h plus 22 is equal to negative 5. This looks like an equation that we have seen already. It's multi-step equation where variables only on one side. I need to isolate the variable, so subtract 22 from each side. We will have 3h equals to negative 27. Divide each side by 3. Then h will be equal to negative 9. I can do another check work to see if my negative 9 was correct. I will do a quick check work right here. 5h plus 2 times 11 minus h equals negative 5, and I'm checking to see if h is equal to negative 9 was correct. I will substitute that into the original equation, so I will have 5 times negative 9 plus 2 times 11 minus negative 9 equals negative 5. This is negative 45 here. 11 minus negative 9 is going to be plus negative together, and I will do 2 times 20. Is it equal to negative 5? That's what we're checking. Negative 45 is still here. Plus 40, is it equal to negative 5? That's what we were checking. And negative 5 is, yes, equal to negative 5. That confirms that our answer is correct. Because this is true, that means, it means the answer was correct. If you end up with a solution where you don't have a true result, then it's an indication that there was an error in your solution, so you would go back and then check your step and hopefully find that error in the solution. Let's look at our next example. Again, distributive property. This time we are distributing on the right side. We have negative 12y minus 3 is equal to negative 10y plus 35. We will gather the variables only on one side. Let's gather all the variables on the left side again. To do that, I need to get rid of the variables on the right side by adding 10y. Let's add 10y's on both sides. These will be eliminated. We will have 35 still on the right side, negative 3 is still on the left side, and our variables would be negative 12y, positive 10y would be negative 2y. Let's add 3 to each side to get rid of the number. We will have negative 2y is equal to positive 38. And divide each side by negative 2. Y is equal to negative 19. Just like earlier, if you would like to check to see if the answer is correct, you can just substitute this value back into the original equation and do order of operations on both sides. Check to see if one side will be equal to the next. Here's your u-try, where you're going to use the distributive property. 14 plus 2 times, parenthesis, 4g minus 3 equals 40. Here's your next u-try. U-try number 4. Negative 3c plus 27 is equal to negative 6 minus 2c. Solve and check your answer. Our next example is a distributive property with fractions. I can distribute the fractions to both of the expressions that are inside of the parenthesis. we will have 1/3 times d plus 1/3 times 3 is equal to 5. These will simplify because this is 3 over 1. And 1/3 times d plus 1 is equal to 5. We will subtract 1 from each side. 1/3 times d will be equal to 4. To get rid of a 1/3, I will multiply it with its reciprocal, 3 over 1, 3 over 1 on each side. These will simplify. Then d is equal to 12. We can again check our work by substituting this value back into the original equation and follow order of operations to see if the left side will be equal to the right side. Let's do one more example. On this example, instead of distributing, I'm going to teach you another trick where we kind of get rid of the fraction. And in order to get rid of the fraction, I know this is also meaning this divided by 5 means everything on this side has been divided by 5. So in order to eliminate that, I'm going to try to multiply each side with the reciprocal right away. If I multiply each side by the reciprocal, it will be 5 over 2 here, multiplication, and multiply this side with 5 over 2 as well. Remember that 14 can be written over 1 as well. These will simplify. We will have 9 over 2b on one side, 5 over 2 times negative 14 over 1 on the next. Now we have taken care of the fraction and the distribution as well. We are going to simplify the left side. 14 divided by 2 is negative 7. 2 divided by 2 is 1. Negative 35 is equal to 9 minus 2b. And let's subtract 9 from each side. Negative 44 is equal to negative 2b. If I divide each side by negative 2, b will be equal to positive 22. I can check my answer by substituting this value back into the original equation. That's here's your U try, and I will make a second part of this video for the remaining sections. Please try this one, and I'll have a second part for this video. Here's U try number 6. 12 is equal to 4 over 3, parentheses 7 minus h. Get rid of the fraction right away by using its reciprocal. Then you can check your work by substituting your answer back into the original equation. Here's our next example. On this example, we will be working with the distributive property first. If we distribute 4 to inside a parenthesis, we will get 8z is equal to 4 times 2 is 8z, 4 times 1 is 4. We know that we are going to gather the variables on one side, and if I were to gather z's on the left side, that means I need to get rid of the z's on the right side. Negative 8z, if I subtract 8z from each side or add negative 8z on each side, this will eliminate the z's on the right side. So on the right side I have 4. On the left side, this part is tricky. Positive 8z, negative 8z, that's 0z. 0 times z is 0. So after we solve the equation, we end up with a statement that's not true. And we also do not have any variables to say that this was a solution. And because there was no variables and the answer, the equation at the end gave us a not true statement, this will be giving us not true statements for any value we can think of for the z. Therefore, there are no solutions for this type of examples. No solutions. We distributed, subtracted, and then we end up with no variables and only numbers on both sides of equal sign, and it's not a true statement. So no solution. Here's the second example of number 7 example. It's also a special case scenario. We can distribute the 2 on one side, and we can also distribute the fraction on the other side. On the left side I'll have 6g plus 2. On the right side, 1/2 times 12. 1/2 times 12 is 6g. 1/2 times 8 is 4. That's plus 4. It looks like I made an error here. 2 times 3g is 6g, and 2 times 2 is also 4. Now if I want to gather my variables on both sides, I will subtract 6g from each side, subtract 6g from each side. These will eliminate, and on the right side I will only have 4. On the left side these will eliminate as well. I have 4 again, and this gives us a true statement. For every g value we can think of, we are going to end up with a true statement. So I can use any g value and it will still give me a true statement. Therefore I can use infinitely many solutions, infinite solutions for g. G can have any value, 1, 2, 3, 4, 5, 6, -5, 100. G can have any values and it will still give us a true statement. For that reason I will say infinite solutions. For this question the answer would be infinite solutions. Now for the last 2 U tries, please check to see whether it's going to be infinite solutions or no solution. This one is 12y plus 6 is equal to 6 times 2y plus 1. Last U try is going to be 2 minus 15n is equal to 5 negative 3n plus 2. That's pretty much it. If you have any questions, please make sure to bring it to the class.